Hey everybody, Mr. Tannen here. So I got some questions with regard to the quiz corrections, specifically this one about 7B. Some of you had written to me or asked me about. So there's one small mistake, and actually I think that was common, and I think maybe I am reflecting, seeing that it happened a good bit, is maybe I didn't teach it as thoroughly as I should. So I think if you do thorough corrections on this question and had gotten the answer originally as 2/3, I'll maybe give you back full points because you'll probably learn the concept just as well by doing the corrections. And I don't know if I had thoroughly explained it. But basically, with this problem, either at the beginning or at the end, you're going to need to reflect on what the sign of the answer would end up being. So because this x is approaching negative infinity, so if it's approaching negative infinity, so this would be a negative plugged in here. Though when the negative is squared, it would become positive. But the negative in the denominator would make whatever ends up simplifying to negative. So uh, sometimes you'll see then a negative just be added at this step. Some of you though just went forward and let me actually write it below here. And you said, okay, well, if this x is approaching infinity, I basically, these are going to be negligible, but be careful. We can't cross, we've got to now, well, then we're just going to have the square root of 4x squared over 3x, which we could then simplify to be the limit as x approaches negative infinity of, okay, that's a perfect square, 2x over 3x. So those cancel. So many of us ended up at 2/3. So either at the beginning I could have done that and then added this negative because I know whatever it ends up being, my answer is negative. Or at the end here, I would have to look back. Once I finish, I can now evaluate the limit because it's just a constant. But I need to consider now, well, my answer, would it be negative or positive given that's approaching negative infinity? Well, in this case, because this is, like I said, going to become a positive over a negative, this would indeed have to be negative. So we need to sometimes, especially if it's approaching this negative infinity, we need to reflect on the original form um, at the beginning or the end of the problem. So either you could have just added this negative here and brought it all the way down to get that, or you could have reflected at the end to do that. Um, People have different preferences. I don't think one is necessarily better than the other. And I know that if you had your grapher, your graphing calculator, if you went to actually graph this function, so let me pull Desmos over, or actually it's good for me to start using the graphing calculator a bit more because that is the one, I know it's a crappy reason perhaps, but it's the one you'd be able to use on tests. Let me make sure it's in the window here. So let me clear out the equation I have here. I'm going to insert, oh, there's this thing here where I can write it as a fraction. So, oops. Oh, I got to turn on my math print to make it more beautiful. Oh, yes. Second square root, what was it, 4x squared um, plus 1 in the numerator, the square root of the whole quantity, 4x squared plus 1, all over the quantity 3x plus 3. And you can see now when I graph it, to the left there, it's approaching this negative value. And I could change my zoom or my window to make my x go much further. But let me leave the y as it is. Maybe I could even make the y. Let's see how it does if I put my x that wild. That will be exciting. Let's make my x min -1, and then let's make my y max 0 so that I just see below, and let's make this a third. Or I wonder if I do 1 over 3, it could be precisely a third. Alright, let's take a look. And you can see even as it goes to negative, forget what I put that as. my window as it goes to negative 1, 2, 3, 4, 5, 6, 10 million. It's right here at 2/3, so it's 1/3, negative 2/3. So some of you may have even graphed it to get the negative, but if you were unable to have a grapher for this problem, you would just need to do that step of reflecting on the original form, like what would the sign be, or at the end on the original form, because this is what determines the behavior of the limit. And sometimes those signs can be lost in our simplification process. All right, much love everybody making this video on a Sunday. No days off. I guess we got to grind every day these days. Oh man, just kidding though. Self-care is pivotal. Make sure you take that time for yourself. Hope everybody's doing well, and I'll see you all soon.